Thank you so much. Hi everybody. I'm here to talk to you about 2030 and a practical roadmap to a QA future. The intent behind this talk is to touch on a number of different emerging areas of automation, talk about different forms of artificial intelligence, particularly in the kind of machine learning, reinforcement learning space, and where traditional automation, scripted automation, and symbolic AI can come together to support a development process and pipeline. It is going to be a bit of a lightning talk. There's a fair bit to cover, but as a quick roadmap, we'll be starting off talking about testing in 2030 and some of the abstract views of that future, giving a bit of a technology 101, so talking about some of the different types of automation tooling that exist, some of their practical applications today. I'll also be sharing a kind of view of that future and a view of some of those tools from today in 2025. I'll talk about leveraging some of the tech that is available today, and then share some tales from the road and experiences with keywords and Mighty Bull and Test. I'll be at the booth after the talk. There's going to be more information on these slides than you'll be able to digest in this speech. So feel free to come up. If you want to have a copy of the deck, more than happy to share. If you want to have a longer conversation about anything in there, feel free to chat as well. So a quick introduction, kind of building on Chelsea's. I started as a PC technician. I started in the hardware space many years ago. Since then, Bachelor of Game Design with honors. I've worked across a number of different roles in the games industry and sit at about 12 years experience. The Australian industry is pretty small. It gives a lot of opportunities to do a lot of different things, but since joining Keywords, I've been really able to specialize and support a team that does exclusively automation, DevOps, and QA support for a number of different teams. And in my role with Mighty Bull and Test, I help to develop some of the technical roadmaps, help to guide some of the client delivery, and support our really amazing, multifaceted team. So some of the projects that we've worked on started with the studio making Disney Crossy Road and contributing to that. We've been working as an automation service provider for Halfbrick for many years. We're also working across a number of different Australian titles. And then we started to go global around 2020. So since then, we've worked with Google on Fitbit Ace LTE, which is a wearable, an entire series of fitness-first games for children. We also worked with a number of different Keywords AI excellence projects to support them. A number of other cool titles like Age of Mythology Retold and Guilty Gear Strive for mobile. And then the upcoming title, Lego Party. There's a whole bunch more that I can't talk about, but some of these are some experiences that we can share. And I'll focus in on Guilty Gear towards the end. The other thing to note is that we've got two different tool families. So the first of those is TestBot. That is bots running a game. That is your more hands-off, headless automation tooling. The second tool that we've got is a product family called TestBuddy, which is designed to augment traditional QA workflows, including LQA functions. I won't touch too much on the TestBuddy component, but again, if you want to have a talk with me about that after this speech, love to have a chat. So, testing in 2030. Technology has solved QA. I don't know if that should deserve an asterisk or just be ruled out entirely, but there is this idea of technology being the holy grail that is just going to solve the QA problem, improve product quality, improve the way that we work and how teams collaborate together. Now, in that journey, there's a number of different views that are coming together to make that happen. We want to interrogate some of those views. But some of the truths that we can perhaps hold is that technology will be widely used in all forms of QA practice, will have alleviated a lot of manual rote work across the process, and the way that we make games and the way that we collaborate together making games will have changed thanks to technology. As a result, hopefully be easier to scope, produce, develop games through to release. The risks in doing that will be decreased and therefore enabling greater innovation and engineering and design for the products that we're making. And the team's quality of life will be increased through the use of technology. And things like first time right will become standard practice or shift left, embraced in the best possible form. The game will 100% always be stable. The team will always be able to see the game in action, and technology will be a lovely discrete budget that sits completely outside of production and we'll all have access to it. Now, obviously, these are not necessarily truths that are going to come through to reality, but this is a projection that I think a lot of people are hoping to make happen. And different teams will be working on different ways to achieve subsets of these goals. So how do we get there? Well, the view from 2025 is that we've got a number of different groups that are working on different subsets of tooling. I would say that there are contested paths to this idea of the Holy Grail, that technology is just going to solve things. It's also, I think, a little bit contested that any subset of these groups has the master key to solve these problems. But one of the views to the Holy Grail is perhaps the technologist perspective. So here, referencing a project from Google, the SEMA tool, which is a tool that allows no-code, black box monitoring of a game, uses computer vision to interrogate what is on screen, and then uses vast amounts of genre mapping to help to pick up any title within a known genre and start to understand and play. At the moment, this tool doesn't exist. There are great research papers in this area. Cost is certainly a challenge. Actually setting this up reliably, particularly if you're doing something unique with mechanics, is going to cause you a challenge. But that is one group of people that are working on one subset of this problem space. Then we've also perhaps got the developer's perspective, the view of different IDE tools, the different engine integrations that are helping to prevent issues from being ever committed to the game's repository. Or tools that are helping in other areas of the pipeline. So that might be art, that might be design features, all of these areas that can then not only help to add new stable content, but also help quickly remediate issues when they're found. There's a lot of investment in this space. There's a lot of credible arguments to why this is going to work and why this is going to support the technology efforts. But again, it's not capturing the full gamut of what QA is. Then thirdly, we've perhaps got the QA engineer's perspective currently today, where we've got different people that are working on entirely different tool families. Perhaps they're integrating, they're working with source control on a regular basis. They're also working with their build pipeline and CI/CD. They're then also working with manual production documents, and that might be Jira, Confluence, Word, depending on how your studio functions. Then capturing video footage, editing screenshots, capturing all of that information, organizing it, triaging it, etc., etc., etc. The point here is that just working with good captured data is still a monumental effort. And so tools that can help to automatically triage bugs, make recommendations about what gets surfaced through to development, and just reduces the overall surface area that somebody has to work with are a really, really valid way to improve and solve time. And if we are not considering all of these different elements and aspects and looking at the problem space holistically, there's not going to be a breakthrough success in your team's adoption of that kind of forward-looking technology. Different viewpoints, solving for different problem spaces. So, a QA Technology 101 of what exists today and what is emerging. There are a couple of different categories that I want to touch on here. So, scripted automation. I want to touch on reinforcement learning as well as imitation learning, their differences, where they can be successfully deployed. Also want to look at computer vision as an emerging area, touch on some large language model and large multimodal AI tools, and then look at symbolic AI as an alternative to some of these. Again, there's more information on these slides than you're going to be able to read, but scripted automation, it's really strong in select areas, particularly if you're very targeted about where you're going to deploy it. In many cases, you don't need for a bot or an agent to play through an entire section of an experience. You can just deploy it in snapshots to capture issues and work quite efficiently. But if the game is changing substantially, frequently, it can be a real issue. So there are places to deploy it, but it's not going to give you full gamut coverage. Whether that's a challenge to your team or not, I can't say, but that's one tool. Reinforcement learning, a lot of discussion about it. It's a topic that keeps appearing at GDC for testing. At the moment, it is quite slow to run, and at the moment, it has quite a limited application. I would say if you're building a game that has a very strong competitive element to it, and you want to be able to identify whether there are potential exploits or potential ways that a high skill ceiling player can uncover mechanics that you have not intended, this is a great tool to use. But for broad spectrum QA coverage, it is not a viable solution today with the amount of compute work that has to go into it. Imitation learning is kind of a nice hybrid approach to that. It allows you to mimic player behavior, so feed in telemetry and inputs, and have an artificial intelligence model replicate those inputs. It does currently require babysitting. So if you were to deploy this, you would need to have a full-time maintenance team to be able to update the imitation learning model as the game content evolves. It's not going to natively be able to make intelligent changes to the game structure change, but it will help you get closer to an agent that is able to make decisions and experience the game. Computer vision. One of the key applications for this technology, and where we kind of borrow it from, is the self-driving world. At the moment, it is not a viable alternative. It may be by 2030, and I think if there is a space to keep monitoring, this is one of them. There are a number of different Python libraries like YOLO that can quite effectively work with retraining to identify game symbols in your title and pull them out and work with the content to be able to play them, but quite compute intensive, quite difficult to use effectively. And again, at the end of this presentation, I'll touch on one of the key details, which I want you to just see if you can pick in advance. Large multimodal models and large language models. Now, we've seen some implementations of these tools where they are doing kind of computer analysis. You're passing images back to a large service provider, a foundation model, having those images analyzed, and the content comes back. It's a very slow loop currently. You're talking about 150, 200 milliseconds of latency at an absolute minimum, so you can't have real-time decision making currently within this methodology. However, large language models as a sort of support tool used in text to drive decisions, to drive behavior, quite useful. To analyze defect information, quite useful. To categorize and find common issues, quite useful. So there are very nice, specific ways to deploy this within your automation tool chain, but to think of this as a singular way to solve the problem space, right now, not necessarily. And symbolic AI. I think that this is an area of tooling that needs a little bit more discussion, because as games, we had for many, many years a lot of really intelligent people working on quite good artificial intelligence that satisfy the needs of a lot of players. There are ways to take our considerations about high-level planning decisions and apply that to game logic and game behavior to be able to drive experiences. You need to work with abstraction to make it resilient. Working in a way that can function across multiple genres and multiple different projects is challenging. But in terms of compute effectiveness and ease of maintaining systems, symbolic AI can be quite robust, but it is a little bit of a learning curve for your team to work with. So different characteristics, different deployments. I think it's also important to consider where in the sort of black box to white box to gray box spectrum each of these tools lie. Now, this isn't going to be always representative of every deployment, but it does give you a little bit of an idea about the information you're working with. Computer vision works great in a black box situation, and I say it works great because it's one of the only tools that can work in an entirely black box situation. If your team needs to test 100% black box only, you're ruling out a whole bunch of different viable alternatives that are on the board. And working in that shade of gray, even though it might not necessarily be traditional, it's really, really useful. You're getting more data out of the engine, you can make more intelligent decisions with that data, and hopefully you can pass that data on to your engineering, designers, artists to remediate and fix issues quickly. It's also important to think about where you might deploy some of these tools in a production pipeline, because they all have different strengths. Perhaps you're working on a title where all of these have a use case. So thinking about where in your production timeline different elements are coming online, perhaps mechanics are being finalized, perhaps you've got a solid gameplay foundation, or perhaps you've got final content, each of these areas can be useful. Now, the last two slides that I'm going to give you here is a view from today about cost and suitability, and a view from the future. Again, not all projects are going to kind of fit neatly with the deployment in this grid, but I hope that this helps to support some thinking, particularly if you're starting the conversation early internally about where you can grow your strength. So what does the 2030 view look like? We're making a bet here, perhaps, that GPUs are going to come down in price, that HBM memory is going to become more available, that cards are going to be more readily available, that server cost is going to become more readily available, that the staffing for these different tools is going to become more readily available. But these are bets that we are making when we're looking at a future forecast in some of these tools. There may be places where it pays off, and the cost-benefit analysis that your team will run for certain deployments makes a lot of sense, but there will be areas where it perhaps doesn't. And I think it's also important to note that when you're looking at foundation model providers, at this point in time, costs are not fully being passed on. There's a lot of subsidization that is happening at the sort of vendor level for some foundation models. So if you're doing a cost projection and you're trying to do a budget for a 3 to 5 year term, you need to think about a potential for those costs to increase as the foundation providers start to work towards recoup on their initial investment and outlay. Now, the key thing I didn't mention here is playing the game is not testing the game.
Thank you.
Right? And that's important for a whole bunch of different areas. So it's important for the quality of the player experience. It's important for design, feedback, like everything. But it's also important when you're talking about an automation deployment that data capture is critical. Feeding that into your team is critical. Having that data be high quality and able to be used by the team is critical, because if you're just creating a tool that plays the game and it looks fun on screen, you're not testing, but you've made a novel toy. Really important to think about. So how do we leverage some of this QA technology in a useful way? So on the journey of making games, you've got a whole bunch of different phases that a project might go through. So I've got a couple of examples here that I'm taking from different experiences that we've had with Mighty Build and Test, supporting different keywords clients. I've mixed up a couple of our experiences, so there's no slide here that represents a single client, but perhaps we've got a roguelike adventure game. It's 25% of its planned team ramp, milestone-based funding, renewed at alpha. Having some initial level tile automation to support a roguelike title is really useful. That is exponential content, which is exponentially annoying and time-consuming to test. So a tool to be able to generate different permutations of a level and have an agent run through and just check that the placement of objects makes sense, check that they can't just fall off a different tile or break out of the game world, really useful. Also something that is going to add value through the entirety of the production, and you can lean on this tool to work more quickly and more effectively. Say you've got an MMORPG, it's 40% of the planned team size, moving to soft launch to adjust the funding for that particular title. Some targeted automation deployment on things like the quest system, the gameplay combat, and the in-game currency store is really useful perhaps, because perhaps those are the areas that are most difficult to engineer. They're the ones that are going through an iteration cycle, and the one where regressions are going to be more difficult to thoroughly conduct on a regular basis. So having a tool that can help check these areas is really useful. And again, in this case, it's just really to get to the next level of the production. It's just to get the team to ramp up a little bit more, to help bridge the effort and to keep things moving. And perhaps we've got a multiplayer cross-platform arcade title. It's a full-size team. They're a little bit behind in their roadmap. Funding's in a difficult place. This happens. Looking at a tool that can work as a dev assistant, where you can have an agent making basic gameplay decisions, but targeted on specific feature branches that allows the team to work in a more agile way for a couple of milestones and then bring all of that content and effort back together, it's really useful. Particularly if it means that you don't have engineers and developers having to kind of shift left their testing by picking up a controller every single time that they're making a new feature and doing a thorough pass before they're committing to main. If they can have a tool that runs that on their desk and they can kind of keep working and monitor the tool, it's really handy. And again, in a deployment like this, it can enable the project to continue. So lastly, just a couple of tales from the road. One of the projects that we've supported at Mighty Build and Test is what I would call an impossible port. And this is a case where technology really did help the project succeed. So the project I'm talking about here is Guilty Gear Strive for the Nintendo Switch. It's a full team, but it was a newly formed team. Excuse me. A lot of the team had experience working on different Nintendo titles. So they were pretty familiar with the hardware platform and the developer tools that existed. But for this project, it's quite difficult, and it's milestone-based funding for the project. Now, before this was announced, the Reddit thread, the Reddit subreddit, there we go, I got it in the end, for Guilty Gear asked a polled question saying, should this be released on Switch? Generally, the audience feedback was pretty negative. There was a view that the Switch couldn't handle the kind of high frame rate, low latency gameplay with rollback as a network feature to support the title. So yes, I'd love to take it on my handheld, but no, I don't think the experience is going to live up to what I have at home. So here, our challenge really was a technical challenge of the port effort, but also meeting the community expectations for the title. So how do we approach it? One of the first things that we laid in was build verification testing or build validation testing. So we spun up a machine that would just run a headless copy of the game, boot it, make sure that everything worked fine. Great, standard practice, first layer to add. The next thing we looked at doing was deploying a symbolic AI system. We call our symbolic AI tooling TestBots that just went through and exercised all UI and UX components within the game. So making sure that every canvas layer element of the title functioned, all buttons worked, and every nook and cranny that was accessible through the surface meta structure of the title was functional, and there weren't any dead ends. Provides automation value throughout numerous phases of development. The next thing that we started to layer in then was more intelligent test cases. So different bots that could go through, look at the input move list that applied to every character and start exercising every single move in sequence throughout the entire game. It then used some of the game's AI model to create artificial opponents. So you could have bot against bot, and we could measure success through the title. And then, once we had that laid in, we started to look at performance automation as well. So we had a number of different devices that rather than running a hard benchmark, what we were doing was running real-time with battery considerations, different segments of gameplay, and when the bot was in different areas of the game, we would record frame rate, we would record all of the telemetry information out of the game, shader cascades, you name it, we captured it. And then for the rest of the duration of the project, we continue to add new tests, report features, data insights to support the team. Now, this didn't mean that the development team for this project stopped making tools, but it meant the tool developers in the team could make specific tools that solved specific problems, right? They're very important to consider as different. So the people that would normally be writing tools got to focus on art pipeline tools, tools that validated the different character assets as they were coming out of the engine, tools that were specifically looking at the shaders in the game and making sure that those were compiling healthily, tools that just helped, right? So we did a lot of different things on this particular title. We provided them with CI/CD systems, including the gold release on cart for the game. We also provided a video streaming system for all of the bots that were in the game running. Being able to see the work really helps you make intelligent decisions about what the bot is doing. So even if it doesn't think there's a problem, you as the human in the loop can see that there's a problem. We also provided performance reports for the team. We did test cases so that they didn't have to worry about any of their smoke tests, except for the ones that they treated as high value, but we were able to just provide results for the rest. And we also provided them reproduction steps automatically anytime that we did encounter a hard crash or a substantial issue. Now, when this was announced, finally, to the community, there was still a little bit of skepticism about what this title would look like. And I think this is perhaps one of the best things that I've ever seen on a subreddit. Great joke. What we ended up being able to produce with the team is a really, really fluid, happy, healthy experience that exceeded the community's expectations. So every move here is not a sprite. These are all 3D models running in-game, very, very complex art pipeline that makes it all happen. And a lot of the times that you see these moves, again, they're not sprites, they're 3D objects that appear in a sort of flipbook style animation on screen to work. There's also a lot of level breaks in Guilty Gear Strive where the player is transported to a different environment. So seamlessly being able to load those mid-match on Switch was its own really difficult effort. And the team actually ended up being able to reduce loading times lower than PlayStation, lower than Xbox, lower than PC, because they had that extra energy to start hunting around for nice-to-haves, not still focusing on the need-to-have elements. So what did that look like from our perspective? We just set up a bunch of different symbolic AI agents to do different things. So some of them would go through and continually test the cutscene system, make sure that the video continued to run through healthily. We also had a number of different bots that would just go through and select different characters from the main menu, load them into a match, exit out of the match, do all of that really basic smoke testing. We also had bots, as I said, that would go through and execute every single move within the dojo and do performance capture for that, and then others that would go through and complete the story campaign. This is not hard to do, particularly if you already have a data set that controls the progression gates for the player. You can start to feed those progression gates back into the agent to be able to get it to progress through your title. And then we also just ran this on a bunch of different dev kits. We set up a screen within their office right near the kitchen so that they were able to monitor the bots as they played and have that observation of the game as it was coming together, viewable by everybody, regardless of the team that they were in. And had some really, really great results back from different reviewers and different members of the community. Really, really, really happy with this project, and the team is as well. Now, there are absolutely problems that I'm sure your team is experiencing, but they probably are quite unique to your team. So thinking about where you are specifically losing time or where there is likely to be risk in an upcoming title is really important. Thinking about all of the different options that are available to your team and how you can work with these new and emerging tooling options is really important. And just thinking about how you're communicating between different departments, different working groups, and how you can collaborate together to come up with solutions that work is also really important. And that's kind of the nature of the talk. What we do at Mighty Build and Test is we support a whole bunch of different teams across the world working on different titles that don't have inbuilt automation experience or don't have DevOps experience or are just starting to learn how they can make use of the tools. We also help to support the rest of Keyword's QA business, moreover, which is what the TestBot tool does. So that's a workflow tool for anyone that is still conducting the manual process. They're able to work with some automation, have some ease of capture, have some nice administrative features to just smooth over the process. It's a tool that's not available externally, but it is part of the Keywords tech stack. We are continuing to try and lead with technology across our offerings. That's a little bit about what we do, and if you'd like to chat more, I'll be at the booth. But thank you very much.